Hello everyone, welcome to online classes for DPS Siliguri for 2020. Myself Somnath sir, and today is my fourth lecture and the topic is electric potential. So what is the definition of electric potential? Well, like electric potential at a point in an electric field is the amount of work done in moving a positive charge from infinity to that point against the electrostatic force. What do you mean by that? So electric potential is equals to work done by the charge particle. Means suppose you have a charge particle Q naught and you have a charge Q. So due to that Q charge, electric field generated, and as you have Q and Q naught, so in presence of electrostatic force. Hope you understand. And if we bring it from infinity to a point P, which is at a distance R, the work done per unit charge particle is called the electric potential. Later on, we derive this formula. Okay, how we get this formula and what is the value of that. Before that, SI unit of electric potential V is volt. Although we can write work done per unit charge particle, so we can write joule per coulomb, but frequently we use as a SI unit volt and it is represented by V. Next thing is that what is the dimension? So for dimension we know the energy means force into displacement. So energy means force into displacement and charge means Q. Now what is the dimension of force? M L T minus 2. What is the dimension of distance? D. What is the dimension of charge? 80. So M L square T minus 3 A minus 1 is the dimension of electric potential. So now again I repeat, electric potential at a point is in an electric field which generated by this charge particle is the amount of work done in moving a positive charge. That Q naught charge is the positive charge or unit positive test charge from infinity to that point against the electrostatic force. Why the electrostatic force? Because you have Q naught charge and Q charge. So now we derive this formula. This formula is very, very important. Let we have a charge Q and we bring a charge particle Q naught from infinity to a point P, which is at a distance R, and due to which we have to do some work done. Now in between this, suppose we bring in that way, in between this, suppose is a point which is at a distance x from the charge particle, and we are suppose further bring it dx distance because see here distance is variable. As the distance is variable, so force is variable, and as the force is variable, so work done is variable. And whenever anything is variable like force or work done, you have to use the help of integration. So at an instant, suppose when the charge particle Q naught at a distance x from the charge particle, and as it is also positive charge particle, and here we suppose this one is also positive charge, so force is repulsive in nature. Now distance or displacement vector and force is a vector, both are vector, and the angle is 180 degree. So we know a very small work done dW, that is F dot dx, and as their dot product we use cos theta and angle is 180 degree. So what we can use F dx cos minus F dx. We also know the value of force from Coulomb's law. The value is 1 by 4 pi epsilon naught q into q naught x square dx. Now, to find out the total work done, we have to take in integration both sides. So, integration, that is your work done, total work done, you can say total work done, that is equals to, you can take the common q naught 4 pi epsilon naught 1 by x square dx, from where? From infinity to point R. And this integration of this work done is, we can write W, and now minus q naught 4 pi epsilon naught, this one is minus 1 by x infinity to R. So this minus plus, so what we can write, q naught 4 pi epsilon naught minus 1 by R minus infinity, so which is equals to 1 by 4 pi epsilon naught q naught by R is your work done. That is very important. And from that, now the potential is work done by that charge particle, which is your unit positive charge particle is q naught. So we can write 1 by 4 pi epsilon naught q naught by R by q naught. This q naught cancel. So we have 1 by 4 pi epsilon naught q by R, whose SI unit is volt. And second thing is that this potential is a scalar quantity. Why? Because the dot product of two vector, we know dot product of two vector is work done. Work done is a scalar quantity and divided by charge particle. So electric potential is a scalar quantity. Very important thing. Now, if we want to compare this value, with electric field, what we find, 1 by 4 pi epsilon naught q by R square. Now, if we want to draw graph between electric field and distance and electric potential and distance, so see what happened. That is very important. See, I think you understand. This one is more stiffer, or that the slope is higher. As the slope is higher, this one is electric field. So this one is electric field. E is inversely proportional to R square, and this one is less slope, or you can say less stiffer. So this one is B is inversely proportional to R. This one is E and V. We write both because we put both. So if we compare for the same parameter, as potential is inversely proportional to R and electric field is inversely proportional to R square, both are hyperbolic shape, but in terms of slope, you can understand this one is higher slope and this one is lower slope. Now the next important part is, suppose we have this point is A, this point is B, and suppose we bring a test charge from infinity to A and then B, or you can say from A and at B. So what happened? Basically we move from A to B. So B is the final position and A is the initial position, and as they are different position, suppose from a charge particle Q, these are two different positions. So we have the potential difference So potential difference always from the final position minus initial position, that is the potential difference. And in terms of work done, we are moving from A to B, so we write work done of AB by the introduced charge particle. So this one is very, very important, and sometimes you have to find out the work done that is equals to charge particle into change in potential difference. This relation is very, very important. This relation is very, very important. Okay, now let's start some numerical related with that topic, and then we move on to electric potential due to electric dipole, which is very, very important. Then we move on to that is called equipotential surface. That is also very, very important. But let's start some numerical. Suppose you have two charge particles. One is 4 microcoulomb, another one is 3 microcoulomb, and they are separated by distance 2. And examiner asks you question: find the position where the net potential is 0. Now see, electric potential is a scalar quantity. This charge is also positive, this charge is also positive. So at any position you can find, at any position, it is impossible to find out net potential is 0. Why? Because both are positive. Positive plus positive is never 0. So you cannot find any position where the net potential is 0. So they don't ask you this type of question. They maximum ask you कि they put you any position. They put you any position like this. Suppose this distance is A, just 2 meters, and this distance is suppose 3 meters. They can ask you to find the potential at point P, or it's very simple. From this point you find out the distance of the two charge particle. Whatever you get the charge distance, then potential at P is potential. We can mention it A and B, and it will be better for us. Potential due to A plus potential due to B. We can directly add them. Why we directly add them? Because they are scalar quantity. So now if you know the distance, I'm just giving it frequently. So I'm just giving it randomly, not frequently. 1 by 4 pi epsilon naught, or you can put the direct value 9 into 10 to the power 9. For A, 4 into 10 to the power minus 6 by distance is 2, plus 3 into 10 to the power minus 6 by distance is 3. So now you understand, 9 into 10 to the power 9, 2 plus 1 into 10 to the power minus 6. So you have 9 into 3 into 10 to the power 3, 27 into 10 to the power 3 volt. So this is your answer. This is the first type of question. Okay, one more thing. Examiner can ask you define 1 volt. Define 1 volt. So see, define 1 volt now is so much easy. We know potential is work done by charge particle. So you need 1. That means 1 joule by 1 coulomb. So how you define? If we bring 1 coulomb charge particle from infinity to a point, so that the work done is 1 joule, then the potential is called 1 volt. Hope you understand. Now they can ask you so many type of questions. Like one more question I want to give you. Suppose they given you plus Q charge, plus Q charge, plus Q charge, plus Q charge, and it's a square, and it's a square. Let it be A, let it be A, let it be A, let it be A. So we can obviously find out the diagonal. Let it be A, B, C, D. So if it is A, it is A. This is root 2A. So we can, if we put it O, so OA equals to OB equals to OC equals to OD, that is root 2 A by 2, that means A by root 2 is the distance from that center point to each vertex. Now, examiner can ask you two type of question. Question number 1, find net electric field at O. Number 2, find net electric potential at O. So now see, for electric potential we know, for electric field we know electric field is a vector particle, so they have direction. For this plus charge, it is moved away, so we can write electric field at O due to A, at O due to C, at O due to D, at O due to B. So they are equal magnitude in opposite direction. How we know they are equal magnitude? See, their strength are same. So in terms of magnitude, electric field at OA, electric field of OB, electric field of OC, electric field of OD equals to 1 by 4 pi epsilon naught Q by, the distance is A by root 2. A by root 2. So at O, they are opposite, cancel each other. So at O, electric field is 0. But what about electric potential? See, electric potential is a vector, scalar quantity. So electric potential at O, that is electric potential at O due to A, electric potential at O due to B, electric potential at O due to C, electric potential at O due to D. Again, same distance, so you just find out anyone's value. Same value there, because we put the same charge. If the charges are different, then their values are different. So the value is 1 by 4 pi epsilon naught Q by, and 1 divided instead. It's a square because it's Q. Here it's A by root 2, and this one is square. Okay, why square? Because the electric field distance is square. So what you have, root 2 by 4 pi epsilon naught Q by A. Now how many potential you have? 1, 2, 3, 4. So potential at 4 is 4 into root 2 by 4 pi epsilon naught Q by A is 4 cancel. So we have root 2 by pi epsilon naught Q by A volt. As we don't give any value, so we can put it that way. If the examiner give you some charge value, some distance, so you calculate it. One more very important type of question they ask from this numerical approach, which is very, very important. Suppose examiner given you, the last one is a similar charge particle, now they given you opposite charge particle, 4 microcoulomb, and they separated by distance 2 meter. Now it's very, very important. See, they can ask you find the position where the net potential is 0. So you can choose so many points where maybe your electric potential is 0. So many points. So examiner not ask you this type of question to find any position where the net potential is 0, because in that case, how many points you find out the position? So it's a little bit confusing, and as it is a confusing, how many points, it's so many, like it's up to infinite point is there. So it's very tough. They give you this type of question, but they restrict you in a particular line. They can say you find the point where the electric potential is 0 in the line joining the charge particle. This one is very, very important. And in general case, most of students find one position. Like see, let it be A, let it be B. We suppose C is a position which is at a distance x from this one and 2 minus x from this one. So you can find out the net potential at C is 0 because one is positive, one is negative. Positive, negative, negative value is 0. So how we find out? At C due to A is equals to at C due to B. As we know, potential is a scalar quantity. So you add them and make them 0 and then you calculate this value. Or as you know, in between this there is a point where the net potential is 0. So you can just find out their magnitude. Then also it's okay. It's your choice in which approach you have to proceed. 4 pi epsilon naught. Now for at C due to A, so 2 microcoulomb by the distance is x, and this one is 1 by 4 pi epsilon naught 4 microcoulomb 2 minus x. You can equalize, then you get the answer, and in that case you don't use the negative sign. Otherwise you can solve it that way also. And in that case what happened? See, one is positive, one is, then you put your nature of the charge particle also. If it is negative, you put negative. If it is positive, you put positive. Then what happened? As one is positive, another one is negative, you can shift it in that side. Again, you get the same result. Okay. Hope you understand. This one is positive, suppose. This one is negative, and as you put the negative sign, plus and minus net 0, you move it on the right hand side. Then that negative become positive, and you get this one. So we specially indirectly skip one step. Now this micro we can easily cancel this 2 to this. So 2 minus x is 2x. So 2 equals to 3x. X equals to 2 by 3 meter. So you get one position. And most of students after solving this, they think they get full marks, and maybe in some examiner give you full marks, but in entrance exam like IITs and all, they check you know it or not. It's not only the one position, you get two positions where the net potential is 0. And the second one is, see, you have one strength is minus, one strength is 2 microcoulomb, another one is minus 4 microcoulomb. Forget the sign. Sign means nature. In terms of strength, this one is higher strength, this one is lower strength. Always choose towards the small strength. I repeat, always choose the sign towards the small strength. Here, this one and this one is small strength. If you write here minus and this one is plus, then also this one is the lower strength. Why? Because 2 is the lower strength with respect to 4. If this one is minus 2 and this one is 4, then you choose that side because this one is then lower strength. But in my question, this one is minus 2 and this one is 2 microcoulomb. So 2 is the lower strength with respect to 4. Don't compare with the negative side and choose the position towards the small strength you get, and it's not in between, either in the left or in the right. Choose the position where the net potential is 0. Let the point is D. So if the point is, as we use already x, so let it use here y. So this distance is 2 plus y. So now potential at D due to A is equals to potential at D due to B. We can solve in that manner also, and we can solve in that manner also, as we already solved this one. So we try to solve this time, because otherwise you can say how we solve this time. So let's see, at D due to A plus at D due to B equals to 0. So 1 by 4 pi epsilon naught at D due to A, 2 microcoulomb, distance is y, plus 1 by 4 pi epsilon naught minus 4 microcoulomb by 2 plus y equals to 2. See what I say, again I am repeating. If you equalize them, don't use sign. But if you this plus this equals to 0, this plus this equals to 0, then use the sign. Because then you adding this to potential and then you get the value 0. But here you know they are opposite strength, so you equalize this. Now if you move in that side, so what happened? 1 by 4 pi epsilon naught 2 microcoulomb by y, that is 1 by 4 pi epsilon naught 4 microcoulomb by 2 plus y. See, you get the same answer, this one and this one. You can directly write it, and that means use just step jump 2 line, and in that case 2 plus y is 2y, which means y equals to 2 meter. So remember, that's very, very important. You get two position, one in between and one either on the left or on the right side. Choose towards the position where the strength is minimum if they are opposite nature. And if they are similar nature, then they never ask you find the position where the net potential is 0. They can ask you find the strength of the electric potential. Now, electric dipole. You already know electric dipole from first session conducted by Sujit sir. This one is a dipole. Two pair of charged particle, negative and positive. You can mention it A and B, separated by a very small distance. Let this one is L. This one is also L. This one is also L, and we know this line is called the axial line and this line is called the equatorial line. So first we have to calculate for the axial position, which is sometimes also called end on position. So we suppose P is a position which is at a distance r from the charged particle. So let this distance is r minus L and this distance is r plus L. Now we have to find out potential at P. So what we can write at P due to plus charge, or you can mention B, and plus at P due to A or minus. See, you don't know if that one is 0 or not, so you don't write they are equal as something like this. You have to find out the net value. So 1 by 4 pi epsilon naught plus q by r minus L plus 1 by 4 pi epsilon naught minus q by r plus L. You can take q by 4 pi epsilon naught common. So what we have, r minus L minus r plus L, which is equals to q by 4 pi epsilon naught r square minus L square, and if you put it here, r plus L minus r minus L. So minus minus cancel. What we have, 1 by 4 pi epsilon naught q into 2L by r square minus L square, which is, you can write here, potential at P or at axial position 1 by 4 pi epsilon naught P by r square minus L square. And in NCRT they use in that manner 1 by 4 pi epsilon naught P by r square minus L square. Try to understand the difference. Here we use P as a vector and we put a map, put a mod. What do you mean by that? Now it's a magnitude, because electric potential is a scalar quantity. And in NCRT they use 1 by 4 pi epsilon P by r2 square minus r square minus L square. And they just put P, that means P is again the magnitude. So both represent the same. It's your choice. You can use this one, you can use this one. Now, if R is very, very large than L, so we can neglect L square as compared to R square. So electric potential at P is 1 by 4 pi epsilon naught P by r square. Or you can write this one. This one is for the axial. Now for equatorial line or broad on side position. So if we consider a dipole, this is the center and this line is equatorial line. So this one is plus q, this one is minus q. We have to find out the electric potential at point P, which is at a distance r from the charge. So we can use this point as well as this one. But I repeat again, potential is a scalar quantity, so don't show any direction. This one is L, this one is L, so this one is r square minus L square, this one is r square, sorry, r square plus L square, this one is r square plus L square. So electric, and if you see this, both are the same distance. So electric potential at P, that is electric potential due to plus charge plus electric potential due to minus charge. So now what happened? 1 by 4 pi epsilon naught q by r square plus L square plus 1 by 4 pi epsilon naught minus q by r square plus L square. And see, everything is same, just one is positive, one is negative, so you can cancel it and make it 0. So it's a very important in terms of numerical, in terms of 1 marks question, in terms of entrance exam also. This one is very important. See, if we consider this line, at any position, potential is 0. So this is the line where potential is same value and potential is 0. Now just try to understand how examiner asks you question from this concept in entrance exam as well as in board exam. Why I am again and again repeating that word? Because without board exam, without 11-12 board paper, or the syllabus is exactly same, without board paper, don't dare to think about entrance exam. That's why I'm repeatedly saying this word. Okay, now this one is the line where the electric potential is 0. Now see how the examiner asks you a question. They give you a dipole. Let P is the dipole and dipole moment is 2 microcoulomb meter, and they choose that point as an origin 0, 0, and that peak point suppose 2, 0, 2 meter, and they put a charge Q that is suppose 4 microcoulomb, and they say what happens in presence. See how they ask the question. In presence of electric dipole 2 microcoulomb meter, a charged particle move from origin, that is from 0, 0 to a point 0.02 meter. The value of the charged particle is 4 microcoulomb. Find the work done during the process. So when they ask this type of question, you are thinking so many things, you apply so many formulas, and then you even get some work done. But the real answer is, see, what is the definition of work done? That's what I'm saying, it's a very important. Charge into del V means potential difference, VB minus VA. So this is the initial position, this is the final position, this one is VB, suppose this one is VA, and both are A and B, both are 0. So charge 0 minus 0 is 0. So work done is 0. So easily CBSE board asks you for 1 marks question, this type of question, they give you 4 options, there will be entrance question. Hope you understand. My next topic is electric potential due to electric dipole at any position. So you have a dipole, P is a point from the center, let this angle is theta. We can use straight. this line as well as this line. Let this length is L, this length is L, and here it is mentioned R is greater than L. Now see, don't use it. See, if this length is L along the basis cos, so we can use this is L cos theta. Similarly, this one is L along the basis cos. This one is L cos theta. So if this one is R, see how you get this one? Total minus this one. So what you write here? R minus L cos theta. Similarly, see, this one is same. These two lines are same. So this one is extra. So what I got this one? R plus L cos theta. So now electric field at point P, electric field into plus charge plus electric field into minus charge, that is 1 by 4 pi epsilon naught, again common. So plus q pi that distance, R minus L cos theta plus minus q pi R plus L cos theta. So what you have, q by 4 pi epsilon naught R square minus L square cos square theta, that is R plus L cos theta minus R minus L cos theta. R minus L cos theta. So R are cancelled. So what you have, 1 by 4 pi epsilon naught P into 2L cos theta by R square minus L square cos square theta. So at any position, 1 by 4 pi epsilon naught P cos theta. We can use P or vector P with mod P cos theta by R square minus L square cos square theta. Now, if R is greater than L, we can neglect L square cos square theta. Why? See, the maximum value of cos theta is 1, and when the theta is 0 degree. Otherwise, 0 to 90 degree. For cos 90 is 0. So any value lies between 0 to 1. L itself small value with the value less than 1. The value is more or less. So again R is greater. So we can neglect L square cos square theta with respect to R square when R is greater than L. So VP is 1 by 4 pi epsilon naught P cos theta by R square. And you can say this one is the general formula. That's why this one is more important. Why? See, if it is an axial position, if this line is in axial position, then theta is 0 degree. And when the theta is 0 degree, cos 0 is 1. So you have 1 by 4 pi epsilon naught P by R square, which is the axial position. If it is 90 degree, then theta is equatorial line. Then theta is 90 degree. When theta is 90 degree, cos 90 is 0. At equatorial, your electric potential is 0. Hope you understand this. So here we conclude my today's lecture. In the next class, we especially go through that equipotential surface, and then some question related to that potential and potential energy. We relate how they are related, and then how electric field, electric potential are related. They are very, very important. These relations are very, very important. And regarding this class, we send some worksheet, and after solving this worksheet, you can send back to respective teachers the links and detail given on that worksheet, in which teacher you have to send it on the basis of your class allotted. For that, today's lecture is we end here. Good night. Bye.